Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore how to perform image classification using generative AI technology. Okay, so let us try to understand the algorithm first and then we'll eventually go to the programming implementation, right? So already in my previous video I have explained in detail about vector database, and along with that another important concept was covered, and that is image embedding. On these two concepts you should have a clear idea to understand the image classification algorithm using generative AI. Okay, so here let me explain how we can perform that. So suppose here let's consider we are having some sample known images. So let's consider here we are having some images of cat. Okay, and here we are having some images of, let's consider, dog, right? So let's consider in a generic machine learning algorithm, if we want to develop for image classification, what we generally do, that is, let's consider here we are having some sort of algorithm. We try to extract some image features, maybe its color histogram or edges, etc. Various features we extract, and using those numeric values we try to train this particular algorithm, and then in that particular algorithm we pass some unknown image, and then we try to classify that image whether it is belonging to category of cat or category of dog, right? So in this particular case what we will do as a first step, let me just erase this particular part. As a first step what we will do, we will pass all these images via embedding model. Okay, that can be Amazon Bedrock Titan embedding, and after passing via this what we will get vectors, right? So those vectors we can store in a vector DB. Let's consider that is Pinecone. Now here in our previous video when we explored the image similarity search, we basically simply stored this kind of image vector representation in vector DB, right? But while storing in this case what we'll do, we will store the vector representation of a single image, and along with that we will add some metadata in the vector database. For example, let's consider this image as C1. So when we will pass via embedding model, we will get its vector representation, let's consider V1. So in this vector DB we will store V1 vector as well as a metadata information we will store its class. Okay, that is cat, because for this particular image the class is known and that is cat, right? So the vector representation along with the actual image class for our training dataset, this combination information we will store in vector database. So like that for the dog image also, for example, this particular image is, let's consider D1, and its vector representation, let's consider we are getting VD1. That also will be storing here with the name VD1 and then comma, along with that we will add the metadata information dog, right? So all I am saying that the only modification with respect to image similarity search here what we have to do is, along with the vector representation we need to store the known class, right? And when we are doing the embedding of these images we already know the class because these are our training datasets. So for training dataset we already have the labels along with us. So just we need to ingest that also along with the vector as a metadata in the vector DB. And now suppose you are getting an unknown class, okay, unknown image, for which we need to classify whether the image is belonging to cat or whether the images belong to dog. So for that what we will do, first we will pass that via embedding model and we will get its vector representation. Let's consider this as test image T1 and the vector representation is TV1. Now here in vector database we will try to perform similarity search, maybe using cosine similarity, and we will try to find out with respect to this vector which vector is most similar. Let's consider with this TV1 this V1 vector is most similar, and then we will look that for this V1 vector what is the class associated with it as a metadata information, and we know for this V1 vector the associated metadata information is cat. So we can consider that because this TV1 vector is highly similar with this V1 vector which is stored in our vector database, and for this V1 vector the metadata information is showing that its class is cat. So that's why we can conclude for this TV1 vector or for this T1 image also the class will be cat, right? So I'm just again repeating these steps. What we'll do, for our training dataset, we will pass via embedding model. We will store the vector representation of those images in our vector DB along with the metadata information, where the metadata will contain class information like cat, dog, etc. Now, when we need to classify an unknown image, as a first step, we will convert image to vector using the Amazon Titan embedding model or some sort of available embedding model, and then we will try to find out the nearest one neighbor. Okay, so KNN, K value 1, like that you can think. Okay, using cosine similarity, we will try to find out the nearest element with which the vector angle is minimum. That means that is most similar vector, and for that vector, what is the class we will try to get from this vector DB, and that class will be basically having for this unknown sample. That's the simple algorithm how we can perform image classification using vector embedding, right? So I hope this particular algorithm is clear to you. Now, without any further delay, we will jump into the programming section. Okay, so for the first step, what we need to do, we need to upload the training dataset in our Google Colab notebook. And I will parallelly run this Photo3 and Pinecone client installation also, because in our this particular demo for the vector database, we are going to use Pinecone. Okay, and now let's see our training dataset. So here we are having a directory called pets. Within pets, we are having two folders. One is cat, one is dog. Within cat, here you can see some images of cats are available, and within this particular directory, some images of dogs are available. And that same folder, basically here I have zipped, and that is available as pets. So as a first step, what I will do, I'll upload that particular folder in our Google Colab notebook. Okay, so I will just simply drag and drop, and here I will click on OK. So let it get uploaded. It is going to take some time depending on our internet speed. And till it is getting uploaded, let's explore the next part of the codes. So here as a first step, we'll unzip the pets.zip file, and as a result, we'll be getting this kind of structure. Within pets, we'll be having cats and dogs, these two folder, and here our actual code starts. So let's explore the code. So here we are basically inputting all the necessary modules. We are creating the Bedrock client using Photo3. This code you will find almost similar as of our earlier code, where we explored image similarity. Only the changes part I will explain in detail, and for the rest of the code detail explanation, you can check out previous video. The link I'll be providing in the description box. Okay, so here as a first step, we are inputting the Pinecone, and here we are basically configuring the Pinecone using API key. The API key you will be easily getting in this particular Pinecone console. Here API key will be getting. If you don't want to use default API key, you can always create a new API key, right? And here we are creating a Pinecone index which will act as a vector database for our data. So I will just create the index also here parallelly. So this is the one, and here the dimension we need to mention. So for our Bedrock Titan multimodal embedding, the dimension is generally 1024. Let's keep cosine similarity enabled, and keeping all other properties as default, I will quickly create the index. So let it get created, and here we have basically defined this particular index. And here let's go to the main function where we are basically calling the image embedding, and here we need to pass the image name. As a first step, we are resizing the image because our Titan multimodal embedding expect the image maximum size to be 2048 cross 2048. So here we have basically created a function called resize and get byte data. Here what we are doing, we are passing the image file, and if the image size is greater than our expected size, we are basically converting using resize function to maximum of this height and width, and then we are getting the bytes data out of it, and we are returning the bytes data. Okay, right? So here we are getting the bytes data, and then we are converting that to base64 encoded data, and then here we are following the format which is required to invoke the Titan embed image v1 model. So that we are calling here response equal to Bedrock runtime dot invoke model. We are passing the body model ID, the accept and content type. These kind of things what we generally need to pass. If you check the AWS Bedrock Titan embed image v1 documentation, you can easily understand this, that this is the expected way how we should pass it. And then we are basically returning the vector representation of the image. As simple as that, right? So I hope these two functions is clear to you. And now here basically our pets.zip file is uploaded. So let me just unzip that, and then I'll explain our next part of the code. Yeah, here it is unzipped. I'll just refresh. and here you can see within pets we are having cat and dog, these two folders, right? Now here I have written a simple function where we need to pass the directory name and it will return all the file names with its absolute path mentioned in it. Okay, so like for example, within cat here we are having image1. So it will be basically giving within content we are having pets, within pets we are having cat, within cat we are having this image1.jpg. So this way complete or absolute file path it will be providing. So that we have basically written a code, and then here image directory we are first passing the image directory for the cat folder which is available within content, then pets and then cat, right? And here we are getting all the absolute file path of the images whatever is available within the cat folder, and then here we will basically iterate in that list one by one. We will get its vector representation and we will store in our Pinecone vector database. So storing cat's data. So basically this particular variable will contain all the cat's images, so that we will now store it. So for storing here what we are doing, we are iterating in those absolute file paths. We are calling image embedding function with the file path and we are getting its vector representation and we are storing in the values. In IDs we need to give a unique ID for each entry, and as I told you that because we want to do classification, so not only the vector representation and the ID will be storing, but along with that some metadata information also will be storing. So because here we are basically storing the vector representation of cats, so here I have written category of cat, right? And now once for all the cats images when we get the vector representation, we are basically executing .upsert command to insert all those vectors along with its category in this particular Pinecone vector DB or index. Same following that same pattern, we are now iterating in the dog folder. We are getting all the image list, we are getting its vector representation, we are storing those information in the Pinecone vector DB, which is same thing, only difference is here now while storing the images or vector representation of dog, we have basically mentioned the category as dog, and then we are inserting the data in Pinecone vector DB, right? So let's execute this code. Here you can see storing cat's data. So here this particular list contains the absolute file path for all the cat images, and what it is doing, it is basically iterating in this list, it is getting its vector representation, it is storing in the Pinecone DB, and now it is basically iterating in the dog folder. Okay, right? And once that operation is done, what we will do, we will basically simply apply a query command to find out the most similar item for an unknown image to classify it properly. So for that, let's consider we are having an image called test1.pet. So let me just show you those images. So here I have taken some sample image. Let's consider this image test1.pet, and here you can easily see that this is an image of a dog, right? But this particular dog image is not available in our training dataset, right? But because vector embedding we have applied, so we can hope that in its vector representation it will have high similarity with one of the dog images and it will be able to detect properly the class of it. So here test1.pet we have uploaded, and what we are doing, we are trying to first convert this particular test image to its vector representation, and we are trying to find out most similar item using cosine similarity, and top k is 1. That means the top most similar item I want to find out, and I am printing the classification. Here you can see that include metadata true. So not only the most similar vector I want to get, but for the vector whatever metadata information is also stored in this particular training layer, that also we want to get. And if you check our Pinecone location, if I just refresh, here you will see along with vector representation, the metadata also got captured and is stored properly in our Pinecone DB. Because here we are not only storing the value, but we are storing the metadata information as well, right? So here let me show you some sample. So here you can see that here ID is provided, which is basically file name, then values is basically vector representation, and metadata is category dog, right? So what we'll do for any unknown image, if we get the vector representation, we'll try to find out the most similar vector. For that, what is the category? That category will be basically the category for our test image or unknown image as well. That we can assume, right? So that's what we are doing here, that we are printing the classification, and from that classification JSON, we are extracting the category from the metadata. So currently I have uploaded the image of a dog, and let's run it. And here you will see that it basically returned first the classification, and here if you see that the top most similar item is having category dog only, right? So that means using Gen AI we able to do the classification. And here basically this particular line is for parsing purpose. From this particular dictionary we are basically extracting the value for the matches key, and then this is an array as you can see, so we are taking 0th element, then within that metadata is basically the key, and within that category is the key, within that dog is the value, right? So this way you can parse the result. If you want you can disable this, that is no longer needed, and if you just simply run this you will get the most similar item of dog. Now similarly here I am having some another image, that is this particular dog image is very vital for different meme template. So here test1.pet2.jpg, and then again top one similar item I want to extract. No need to print the classification, directly we can run it, and here also we can hope that it will return dog, right? Because here for this image vector representation it is able to find out most similar vector somewhat belonging to dog category only, and this category is basically helping us in classification, right? So remember this metadata component. This is playing a very vital role in this classification process. And similarly I can show you one sample for cats. For example, this image I can upload, and as here you can clearly see this is a cat image, right? So here if I just pass this image vector representation, if we try to find out most similar item, and if I just execute the query, here you will see cat, right? So this is how basically image classification you can implement using vector embedding and our Bedrock Titan multimodal embedding. Only hint is here when you are storing the vector representation for the training dataset, you also store the metadata information. That way it will be helping us in fetching the nearest similar item for the unknown images. I hope you understood this. The complete code and the algorithm I'll be providing in the description box or in the comment section. Try to play with it. If you have any doubt in any part of the code or in the explanation, please mention the timestamp and your doubt in the comment section. I will try to reply back ASAP. This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.